Okay, so you want to learn about roof math. All roof math comes down to a singular formula, which is Pythagoras' theorem, which is a squared plus b squared equals c squared. A squared plus b squared is equal to c squared, which if you were paying attention in maybe junior high or who knows when, you learned this formula for a right angle triangle. So you have a right angle triangle like this. So we draw a square there to indicate that this is a right angle, this is 90 degrees. You have side A, you have side B, you have side C. And the square of these two sides always equals the square of this side. Okay? And this is the basis of all roof math. So we don't need to overcomplicate things by introducing sine and cosine and tangents and all those types of things, because we can get it all done with this simple formula. Okay? So almost every type of roof is made up of triangles. Generally speaking, they're flat surfaces. So they're just the sides of triangles. So this would be like a gable roof. This would be like a simple cottage roof. So this triangle is going to be broken up like this. And you have an upright portion and you have a horizontal portion. The upright portion is the A, the horizontal is the B, and the slope of the roof is C. All right? So we can work through some examples to show what we're talking about here. So let's say that this roof is a 612 roof. So we can talk about having a unit triangle. Of 612, okay? And then we can solve the rest of the triangle by putting it into the calculator here. Or you can look at a framing square because all the numbers are there as well. If you look at a framing square, you'll see that the number is probably 13.42, which indicates this side here. Just to show you what we're talking about, we can put it into the calculator. This app, by the way, is excellent. It's called Calculator++, and I highly recommend it. Okay, so we'll say 6 square plus 12 squared. Okay, so that gives us 13.41, which is rounded to 13.42. All right. So when you solve this, you get 13.42 as the completion of your unit triangle. So if you were to divide 13.42 divided by 12, so let's divide it here, you get 1.12. So that means that for every 1 inch I go this way, I go up here 1.12, all right? So similarly, you could go the other direction and say we have 13.42 divided by 6. That'll give us just twice that because I chose an easy number to work with, so that would be 2.24. Let's just prove it to ourselves over here. 2.24. So that means that for every inch you go up, you're going to go 2.24 that way. So we know that if we just move in this direction, we're going to go up this way. And if we move in this direction, we're going to go up this way. So this is the basic, when you understand this concept, that for every little bit you go this way, you go the same sort of ratio, proportion that way, and the same sort of proportion that way, always. So those three values are always linked. Once you know your pitch, which in this case we're saying is 612, once you have that locked in, you're going to go a certain direction, a certain amount this way, and you're going to go half as much up, because we're talking about 6 is half of 12, and we're going to go up the slope by 1.12 for every inch we go this way. So once we have those ideas down in our heads that this is how roof math works, going this way, you're going up, and you're going up this way. You're going up the slope and up vertically. Okay, so let's work through a sample example to show what's the actual practical implication of this. So let's just pretend that this house that we've drawn here is 16 feet wide from here to here. So that means to this point it's 8 feet, which is 96 inches. Okay, so using our calculations here and here, we can say that if we go 96 this way, we're going to go up half as much because we're talking about 612. So you could say 96 times 6 divided by 12 to get up that much, which is going to give us 48. So that would be 48. Okay, and then we could just automatically figure out the slope by saying, take this unit triangle here of the 1.12. Okay, so if we say by 12 times 96 is going to give us 1.07.33. So this is going to be the length from here to the peak. All right, so 107.33, which is going to be about 5/16. Okay, so that we haven't really talked about the overhang yet, but that would be if you're going from this point to this point, from the peak to the edge of the wall, because we said that our building is 96. So once you understand this, we're good. Okay, but it does get kind of tedious, like having to work this stuff out, especially if you're on a job site and you're basically having to do this on a block of wood. It's kind of a pain. So I invented an app for this purpose, and I call it Square Triangle. You can get it from from Google Play right now, and I'll have it available on the Apple Store soon enough. Okay, so here, seeing as we're going to set the pitch to 612, and we're going to set the run to 96, and that tells us that we're 107 5/16. Okay, so this also makes it really easy to factor in other stuff. So we probably have a ridge beam here, because it doesn't make any sense to be building a rafter right to the peak. You'd have some sort of a beam or something that it would be sitting on. So let's say that this is a 2-ply 2x12 beam. So then we're going to take off 1.5 inches up here, and let's pretend that we have a 2-foot overhang, and so we're going to add 22.5 because you're going to have 1.5 inches of fascia. So minus 1.5 inches for the fascia, you're going to add on 22.5. So we're going to take off 1.5 inches up here, and we're going to add 22.5 down here. And so overall that means that we're going to add 21. So then that'll be 117. So to calculate the actual length of our rafter, we just put in 117. And that's going to give us length for the rafter of 130 and 13/16. So that is the actual length that the rafter needs to be for us to cut it. So from that point to that point, or from that point to that point, it's the same thing. But you probably want to cut a bird's mouth into it, because let's say you're landing it on the outside wall, so you need to cut a bird's mouth into it like there. So then you need to come in the 22.5 to the inside of your bird's mouth, or if you wanted to go to to the inside of the wall of your bird's mouth, and that would be 22.5. So you need to come across this way, 22.5, or 22 or 26.5. So all we need to do is put that into our calculator. So then you just need to come up the slope 25 1/8. So from this point to this point, 25 1/8. Or if you want to go to the inside, you could go 26. So that would be, from to that point would be 29 5/8. So you can see how this calculator makes it very much simplifies the process of calculating your rafter lengths, and makes life a lot simpler and easier. So in the next video, I'll show you how to use it for calculating hips. All right, so I hope you learned something, and let me know what you think.